Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. The first thing to do when working out what angle things need to be on a pie chart is to add up the frequencies. So we're going to do 14 plus 7 plus 3, and we find out that that's 24. Then we're going to find the angle that one item would be. So one item is going to be, well, there are 360 degrees in a triangle, and there are 24 items. So we're going to do 360 divided by 24. And that gives us 15 degrees. So each item is worth 15 degrees, or will take up 15 degrees. So to find out the angle for red, well, we've got 14 items, times it by 15, and that will give us 210 degrees. And we're just going to times each of these by 15, which would be 105, and the final one times 15 is 45 degrees. Add them up and they add up to 360, which is good. They need to add up to 360. So we get our protractor, rest it on a pie chart. Now we know 180 is down here, so the first thing we're going to do is just mark that on, because the first angle is going to be 210. So we know that's 180 so far. So I'm going to turn my protractor around, and from 180, 210 will be another 30. So I'm just going to plot that on. And then I'm going to join it up. So start at the center and join that up. And we're going to stop when the circle stops. Then to do 105, we're going to put our protractor in the middle. And we're going to look at 105, which will be up here. And then we're just going to join it up with a straight line. And then we're just going to check the last angle. And so if I put my protractor on it, and it is 45 degrees. Perfect. Now, an important step to not miss is you need to label them. And so the first one is red, the second one is blue, and then the final one is other. All probabilities have to add up to 1. So what I'm going to do is I'm going to take away these probabilities away from 1. So we're going to do 1 take away 0.09 plus 0.13 plus 0.18, and so that's going to be 0.4. 1 take away 0.4 is 0.6. To find the factors of 30, we're just going to write down all the factor pairs, or all the pairs of numbers that multiply together to make 30. So 1 times 30 is 30. 2 times 15, 3 times 10. Now 4 doesn't go because 30 is not in the 4 times table. 5 times 6, and we notice that if we pick 6, it's just going to be 6 times 5, it's just going to be the opposite. So the factors are all the numbers that we've just written down, so it would be 1, 2, 3, 5, 6, 10, 15 and 30. So for this question, we need to understand that the units we currently have are in meters per second, and the units we want to get them to or convert them to are kilometers per hour. Now to convert the meters part is quite easy, because all we need to do is divide by 1,000, and when you divide the top of a fraction by 1,000, all you do is you just divide the whole thing by 1,000. So we're just going to divide the whole thing by 1,000. So we've got 95, and we're going to divide the whole thing by 1,000, so we get 0.095, and that's going to be kilometers per second, because we haven't dealt with the seconds yet. So that's the easy part. The more difficult part is converting the seconds to hours. So to convert seconds to hours, we divide by 60 and then divide by 60. So we divide it by 360. Seems simple enough. But the seconds are at the bottom of a fraction, and when you divide the bottom of a fraction by something, you actually times the whole fraction by that thing. So we're going to times the whole fraction by 360. And so we do 0.095 times 360, and you get the answer of 342 kilometers per hour. So our answer is 342 kilometers per hour. So to draw this straight line graph, what we're going to do is just pick three x coordinates, which is -2, 0, and 2. So I'm going to start off with -2, and I'm just going to substitute it into the equation we've got here. So y equals -2 times -2, because that's what we're putting in, plus 8. -2 times -2 is positive 4. So it's going to be 4 plus 8, which is going to be 12. So at -2, our graph is at 12, which will be here. Then we're going to put in x equals 0. So it's going to be y equals -2 times 0 plus 8. Anything times 0 is just 0, so it's just going to be 0 plus 8, or just 8. So it's going to be 0, 8 will be our next coordinate. And then finally we've got x equals 2. So it's going to be y equals -2 times 2 plus 8. -2 times 2 is going to be -4. And -4 plus 8, which is the same as 8 take away 4, so that's going to be 4. So at 2 it's going to be 4. So we get our ruler to be able to draw this in. We try our best to make sure it's as neat as we can, and make sure it continues on for the whole graph, so no gaps. To work out the circumference, we need to first of all work out what the diameter of this is, and to do that we just draw a line across the circle, and we can see the diameter is twice as big as the radius, so the diameter is going to be the radius times 2, which is 28. Formula for the circumference of a circle is just pi times the diameter, which will be pi times 28. Now to write this in terms of pi, which the question asks for, we just put the number first and then pi, so it will be 28 pi. Just like when you're simplifying fractions, you can't have decimals at the top and bottom. You can't have decimals at the top, at the left and right of a ratio. So we're going to have to get rid of this decimal. And the way we're going to do that is just simply times each side by 10. And that will leave 4, and that will be 60. Now we can simplify this further, because I can divide left and right by 2. So that would be 2 to 30. And I can actually do the same again. I can divide them by 2 again. And that would be 1 to 15. Now you might have just divided by 4, and that would also give you the right answer. In fact, there's a couple of different methods that you can get the same answer with. So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the 2 2's together to make 4, and then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20. So we times that by 4. And so we've got times the top by 4 as well to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it'd be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 and 3/20. And we can add the 4 and the 1 together to make 5 and 3/20. So the answer is 5 and 3/20. It's important to remember our speed, distance, time triangle. So we've got speed equals distance over time. And here we are given a distance because from here we're 16 kilometers away from home. So the distance, let's just draw another triangle, the distance will be 16. And we're told that the speed is 32 kilometers per hour. So the speed is 32. So to find the time, we're going to do 16 divided by 32. So the time is a half an hour. And half an hour would bring us, if we start here, half an hour would bring us to 2030 because it's 8 o'clock where we start and we end, therefore, half an hour later. So to find the locus of points that are 10 centimeters away from a point, you need to measure 10 centimeters on a pair of compasses, and then you put the point at A and draw them. Now I'm going to try my best to do this. It's probably not going to look perfect, but I'll do my best. And the length here, which is supposed to be, probably isn't exactly, but this part here is going to be 10 centimeters to get the full marks, and obviously you want the circle to be a little bit nicer than the one I've drawn, but try and get it as perfect as you can. And the best way of doing that is just don't push down too much and just move the page around with your compass being stationary. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across that. And what I'm going to do is just draw ray lines from the centre of enlargement. And we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here. And so that would be -4, 1. The first thing to notice is that the tree must be closer to CD than AB. So if we draw a line across the middle, it can't be in the top bit because that would be closer to line AB. The second piece of information that is given to us is it must be at least 11 meters away from point C. So we get our compass out and measure 11 centimeters, or whatever the scale we're using in this diagram is, and we draw a quarter circle from C. And it says shade the region that it can be planted. So this is the region that represents closer to line CD than AB, but also not within 11 meters of point C. So we need to first of all work out the amount of machine minutes it takes to make a toy. And what we do is we multiply the amount of machines by the amount of minutes. So 5 times 40, which would be 200. So if we had one machine, it would take 200 minutes to create one toy. Here we asked, well, okay, what if we wanted a toy every 8 minutes? So we get the 200 and we divide it by 8. And when we do that, we get 25. So if we had 25 machines, we would be able to make it every 8 minutes. And the logic here is 5 machines. So this is machines, and this is minutes, is 40. Then 8 minutes, if you think about it, we divide that by 5 to get to 8. And so if we divide the amount of minutes by 5, we actually times the amount of machines required by 5. So this is called an inverse relationship. So if one doubles, the other halves. If one divided by 5, the other will times by 5. So our answer here is 25 machines. Sometimes it's easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions you can just times the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0. So that's going to be 500. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, not right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here, and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done Surds yet, or you aren't doing Surds, is you times Tom 1 by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here, because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it would be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. So we need to first of all work out how many black and red counters there are at the start. Now if you look at the fraction of the probability of picking a black, in your first pick is 2 over 5, and then the second pick is 1 over 4. So you can see that there's 1 less at the numerator and then 1 less overall. So that means we can conclude that there are 2 blacks at the start, 2 black counters, and if there are 2 black counters and there's only black and red counters, then there must be 3 red counters, so that to make up the fact that it's 2 over 5. Okay, so to find the missing probabilities, the first couple are quite simple, because we know that, let's do a different colour, this and this have to add up to 1. And so if the probability of picking a black there is 1/4, then the probability of picking a red must be 3 over 4, because these have to add up to 1. Same with these two, these have to add up to 1. So if we've got 2/5 at the top, the bottom one must be 3/5. And finally, we've got these two here. Now these two here we're not given any fractions for, but given the fact that we started with 2 black and 3 red, we've picked one of the red, so we've got 1 less red, and that means we've got 2 black counters and 2 red counters. So it means that the probability of picking a black is 2 over 4, or 1/2. And the probability of picking a red is 2 over 4, or 1/2. When we multiply numbers, it doesn't actually matter which order we multiply them. So I can actually rewrite this as 7 times 9 times 10 to the power of 2 times 10 to the power of 9. 7 times 9 is 63. And 10 to the power of 2 times 10 to the power of 9, we add the powers, so it'd be 10 to the power of 11. Now here we've got a problem. It looks like standard form, but it is not standard form, because standard form has to be a number between 1 and 10, but not including 10. And here we've got 63. So what I'm going to do is just quickly write out what number this is. So we've got the decimal point here. And you don't need to do this, but I find it a bit easier to show what we're doing. So here we've got 10 to the power of 11, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We fill these all out with zeros, and that's the number we've created here. A lot of zeros. Now, to make it a number between 1 and 10, not including 10, the decimal point, it needs to be here. So we want that to end up with 6.3 times 10 to the power of, well, let's work that out now. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 10 to the power of 12. Now you don't need to do all the working out I've just shown there. You just need to know when you convert that 63 into a 6.3, you need to add 1 to the power. We can write the equation of any linear graph as y equals mx plus c. So m is the gradient and c is the y-intercept. So we've got to find what the gradient and the y-intercept are. Well, I'm going to first of all try and figure out what the gradient is, because we're actually given some clues here. We're told that the line is perpendicular to the equation given. Now I'm going to rewrite this a little bit just to make it a bit clearer what the gradient of this is. So I'm going to write this as minus 1 over 12. I'm just going to leave a bit more of a gap there. Minus 1 over 12 x plus 12. And you can see that the number before the x, the coefficient of the x, is minus 1 over 12. But we're not told that it's parallel to that, so it's not, the equation that we've got is not going to have the gradient as minus 1 over 12. We're told it's perpendicular. Now, when two things are perpendicular, to find the gradient of the other one, if we know one of them, you've got to change the sign and find the reciprocal of the fraction. So to find our gradient, we're going to change the sign, so it's negative, so our gradient is going to be positive, and we're going to flip it. We're going to find the reciprocal. Reciprocal of 1 over 12 will be 12 over 1, or just 12. So the gradient of our line is going to be 12. To find the y-intercept, we're going to use the points given to us. So we've got x equals 3 and y equals 4 for a point on our line. We're going to substitute those into the equation we've got. So it's going to be 40 equals 12 times 3 plus c. Put in our solving lines. 12 times 3 is 36. And we're going to take away that 36 both sides. So it's going to be 4 equals c, or c equals 4. So our equation will be y equals 12x plus 4. Here we're told that y is inversely proportional to x squared, so we've got y is proportional to 1 over x squared, that's what inversely means. And we want to change that proportionality sign for an equals, and to do that we need to times the right hand side by k. K represents a constant. Next step, we're going to put in x equals 7 and y equals 137.2 to find out what k is. So 137.2 equals k over 7 squared. Well, we know 7 squared is just 49. I'm going to solve that by timesing both sides by 49. And when we do that, we find that k is equal to 6,722.8. Going to get that equation we wrote earlier, and we're just going to rewrite it, but we know what k is now. We know it's 6722.8. And we're going to rewrite that to find out what x is when y is 34.3. So we're going to substitute the 34.3 in. And there's a little trick here. If you've got the unknown at the bottom, what you can do is actually just swap these two over. And effectively what we're doing there is timesing both sides by x squared and dividing both sides by 34.3. So we've got x squared equals 6722.8 over 34.3. And then we want to solve it, so get our lines in, square root both sides. And when you square root, that fraction equals 196, square root it, it will equal 14. So our answer is x equals 14. Okay, so we're just expanding this similar to when we expand a quadratic double bracket. And so you can choose any method you want. I'm just going to choose the grid method, but it doesn't really matter. You pick a method you're comfortable with. So we've got 4 root 7. And we've got 9 and then minus root 7. So we're going to do 9 times 4, which is 36. 9 times root 7, which is just 9 root 7. 4 times minus root 7, so that'd be minus 4 root 7. and then minus and a positive make them negative, and then root 7 times root 7 is just going to be root 49 because you times together the number inside the surd, and then root 49 is just 7, so that's just going to be minus 7. Then we can add these two together, which will give us 29, and then we can add the surds. So actually it's going to be taking away because we've got minus 4 root 7 there. So 9 root 7 take away 4 root 7 is going to be plus 5 root 7. Compare it to the question, a plus b root 7. The a would be 29 and the b would be 5. So for this question, first thing to notice is there's a divide there, and we can actually just write this as a fraction. So 10 plus root 2 over 14 plus root 2. I'm going to keep the brackets there. We don't need them when it's in a fraction, but it will help us for the next step. So we're asked to transport this or change this into a fraction without a surd at the bottom. And so it's basically asking us to rationalise the denominator. Now, when you have two terms, including a surd at the bottom, we need to do something a bit special with this. And the thing we do is we times it by the opposite bracket. And what I mean by that is if it's 14 plus root 2, we times it by 14 minus root 2. And we've got to do the same to the top. And the reason for that is essentially here all we're doing is we're timesing it by 1, because 14 minus root 2 over 14 minus root 2 is just 1. So we're timesing it by 1, so we're not changing the fraction at all. Okay, let's draw a grid to work out what that will equal. And you can use any method you want. You can use double smiles and rainbows, FOIL, whatever method you have to multiply two sets of brackets. I'm going to start off with the top. The top is 10 plus root 2 times 14 minus root 2. So 14 times 10 is 140. 14 times root 2 is just 14 root 2. 10 times minus root 2 is minus 10 root 2. And then a minus and a positive make a minus, and root 2 times root 2 is just 2. Now, when you expand surdy brackets, these two and these two will add together. Okay, so we're going to start off with the numbers. 140 take away 2 is 138. And then we'll do the surd. So 14 root 2 take away 10 root 2 is plus 4 root 2. Okay, so the top is going to be 138 plus 4 root 2. And let's do the bottom. And I like these grids because you can see if you've made any mistakes quite quickly with these. You can check your working. So 14 plus root 2 times 14 minus root 2. And you'll see why in a second we do the opposite. So 14 times 14 is 196. 14 root 2 minus 14 root 2 and then minus 2. So you can see here now there's a 14 root 2 plus minus a 14 root 2. Let's just cancel each other out to 0. So we get rid of the surd. And then 196 take away 2, which is 194. So we've got 194 at the bottom. Now something we notice here is that all the terms in the fraction are even, therefore we can halve everything. So 138 halved is 69. 4 root 2 halved is 2 root 2. And 194 halved is 97. And so that would be 69 there, and that would be 2, and then that would be 97. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.